Welcome to Unit 8, Lesson 2. Sorry about that. I went to unpause or pause. I don't remember what I hit, but I accidentally stopped the video. And you can't, when you press stop, I can't restart. Anyway, so this is the second part. We just finished multiplication division. Now we're moving on to addition and subtraction. Okay, so adding and subtracting. So let's take a look at our basic fractions, meaning no variables. All right, so if I asked you to add 1/3 and 3/4, you know that you have to find a common denominator. Unfortunately, not as basic as multiplication where we can just start multiplying things. Here we need a common denominator. So for numbers, nothing too crazy. Okay, common denominator between 3 and 4 is 12. That is the smallest number that they can both divide into evenly. Sometimes we find that LCD by multiplying the two denominators. Sometimes there's something smaller, and we'll see that in our next example. But it's 12, so then of course whatever you do downstairs, changing, you have to do upstairs. So we want to say to ourselves, okay, what's the missing factor here? Meaning, what did I multiply 3 by to get to 12? 3 times 4 is 12, so I have to multiply this numerator by 4. Okay, so that is that. Now over here, 4 times 3 is 12, so we're going to do 3 times 3. And then I can simplify my numerator, so 3/12. All right, well, what happens when we add some variables in? So the first step is to factor everything. Now in this first couple examples, it's really going to be nothing to factor. We're just going to start, adding fractions. But when we get down to the big ones, we're going to factor everything, find a least common denominator, and then make sure we multiply our numerators by those missing factors that weren't in the original denominator. I'll show you what I mean by that. And then, of course, simplify that numerator. So looking at this one, my two denominators are 4 and 8. Now we don't need to multiply them together to get 32. You certainly can do that, but you're just going to have more factoring to do and reducing to do at the end. So if you can get that LCD from the get-go, it's less work later on. So 4 goes into 8 evenly, so let's just leave 8 as our LCD. So what's the missing factor here? Meaning, what did I multiply 4 by to get to 8? 2. So I got to do 2 times 3x, which is 6x. What am I multiplying 8 by to get to 8? 1. Okay, so 1 times x is x. So that just stays. And then I combine my like terms. So 7x over 8, no big deal. All right, now over here. Number 2, we've got 3 different fractions, and we've got a variable in our denominator now. So when finding the LCD, let's go ahead and let's just take a look at our coefficients first. 6, 3, and 4. I want to find which factor, okay, appears, or which number they can all divide into evenly, the smallest one, and it's 12. Now, one way you can do that is to kind of list out the numbers that you've got going on. For 6, I have 2 times 3. For 3, I have 3, which is already in my LCD list. For 4, it's 2 times 2. Well, the 2 already appeared once, so if I write the second 2, when I multiply those together, that gives me 12. So I kind of just broke down the numbers into their factors. It's another way to look at it. Now, if you notice, each of them also has an x. Now, I'm not going to write x cubed. I just need to write it looking at each denominator separately the greatest number of times I see it. So I only see x one time in each denominator, so I only need 1 down here. Now, if you did an x cubed, that would just mean you'd have to change your numerators and reduce at the end. So we don't need to do that. All right, so let's go with the first one. To get from 6x to 12x is just times 2. To get from 3x to 12x is times 4. To get from 4x to 12x is times 3. And that's a minus, so just be careful. So then when I simplify that numerator, 2 plus 8 is 10, minus 9 is 1. All right, so 1 over 12x. All right, number 3. Okay, let's take a look. So I see a's and b's, so I know I need a's and b's, but we've got exponents here. Okay, there's no numbers. So look at your a's. In the first fraction, I only have a 1 time. In my second fraction, I have it twice. So that means I need to see it 2 times in my LCD. Okay, I can't just put 1a because then this guy's got more than what's down there. Your least common denominator can't be smaller than the biggest factor you have. And I also need a b squared because this denominator has b squared. So I've got a squared and b squared. So now when you look at it, you say, okay, in this first denominator, I have a and b squared. What's missing? What's down here that's not up there? One of the a's. So I've got to do a times a minus b. In this next denominator, kind of drew all over it, but you have a squared b. So what's down here that's not up here? One of the b's. So I'm going to do plus b times a plus b. Okay, so I multiplied each numerator by the missing factor, by the factor that appeared in my LCD that did not appear in the original denominator. Now, if the LCD is the same as a denominator, then you don't have to multiply by anything, and woohoo, that's easier. All right, so now I'm going to simplify that numerator by distributing an a. So I have a squared minus ab. Over here I can distribute, giving me ab plus b squared. And then simplify. What can I do here? The negative ab and positive ab cancel, so here's what I'm left with. Now, can you factor that? Because at the end you have to say, okay, can I factor and cancel? No, I can't factor because it's a sum of perfect squares, which is not factorable. I can only do it for differences. So that is done. All right, taking a look at number 4. Okay, I don't have any numbers and I don't have any common variables, so let's make a list. So as we get into more complicated ones, I like to make a list of the factors that appear. So I'm going to go through each denominator and just jot down the factors that I see. Okay, and we kind of did that over here because we saw an A, then we saw a B, and we said, okay, there's 2 of each. So here I have an A in the first denominator. And in my second denominator, I have an A minus 5. Now, these two A's aren't the same because remember, this is attached. A minus 5 is attached as 1. So that is my LCD right there. It's A times A minus 5. Okay, it looks a little bit different because we have variables now. But everything needs to appear. If a factor appears in one of the original denominators, it has to show up in the LCD. Okay, don't multiply it out, leave a factor. So now we have to go through and talk about the missing factors. So what I like to do is I take a look at each fraction one at a time. So I'm looking at this guy first and I'm saying, okay, that one had the A in the denominator. So I kind of go through and this helps as I have more factors to deal with. But I go through and I check off the ones that appeared and whatever's not checked off is what I'm going to multiply my numerator by because that's the missing factor. So here I'm going to do 2 times A minus 5. And my second one, I've got A plus or A minus 5. But I don't have the A, so that's what I'm going to multiply by. Now, is that a plus? Sorry. Okay, yes. Couldn't read. So plus 3 times A, which is 3A. All right, now, simplify. Do not cancel things out. You can't do that. You've got to simplify that numerator. So distribute the 2, which leaves me with 2A minus 10 plus 3A. If you kind of want to simplify that numerator and then put it back over the denominator so you're not writing the same thing 10 times, that's fine. So I've got 5A minus 10. Okay? Can I factor now? Yes. This I can pull a 5 out of. So leave your answer in factored form. So I had to simplify, distribute, combine like terms, factor if I can, and then see if anything can cancel. Nothing can cancel here, so I'm done. This is my answer. In some cases, you will be able to cancel, but we'll get there. That is my answer. All right, let's take a look at the next two. Now, in all of my previous denominators, I didn't have to factor. Everything was already factored for us because we were just kind of working into it. But notice here I need to factor those denominators. That's okay. All right, so let's go ahead and factor this one first. That factors into x minus 6, x plus 6. This factors into x times x plus 6. So let's make that list of LCDs of all the factors we see and kind of just go through and jot it down. If something already appears, you don't rewrite it. All right, so I see an x minus 6. I see an x plus 6. I see an x. I see an x plus 6, but that's already on my list. The only time I would write the same factor more than one time is if it appears in one denominator more than one time. So for example, if this first denominator had 2 x plus 6's, then I would see the x plus 6 appear more than once. All right, but if it's in both denominators, that just means I'm not going to have to multiply anything by it. So this whole thing is my LCD, what I just made my list out of. All right, now we can go through and check things off. So my first fraction, I have the x minus 6 and the x plus 6 in that denominator. So I'm checking them off. I don't have the x, so that's what I'm multiplying the 2 by, 2 times x. In my second fraction, I have x and x plus 6. I don't have the x minus 6, so that's what I'm multiplying by. Now please be careful because this problem's a subtraction. So it's negative 1 times x minus 6. So I can go ahead and simplify that numerator. Do not cancel. That will always be the last step. And I'm going to distribute the negative 1. So I have 2x minus x plus 6. So that gives me a positive x plus 6. Now, very final step. Can I cancel anything? Yes, the x plus 6. So you're left with 1 over x times x minus 6, and that is my answer in simplest form. All right, and let's do this last one together. Now, before we even get started by factoring, there's something that you may notice here. Your two denominators are opposites. So I don't need to sit there and factor. Well, I will need to factor, but I don't need to make the list yet because let's take care of those opposites. We don't have to first, but it will be a lot longer. 2x minus 6 is the complete opposite of 6 minus 2x. So what I can do is I can switch around that second denominator to 2x minus 6 and change this to a minus. So really I multiply that second fraction by a factor of -1. Okay, so now I have the same exact denominator. So at this point, I can factor, or I can simply just combine like terms and then factor, meaning I can put this over one fraction. There's my LCD, 2x minus 6. Okay, they both have it. I don't need to change any numerators. So I can just write 3x minus 9. And now I can go ahead and factor and cancel, okay? We could have factored first and had 2 and x minus 3 over here, because that's what they both factor into. Same thing, all right? But just showing you that if they're opposites, just take care of that first. It will make your life easier. So I've got 3 times x minus 3 over 2 times x minus 3. Those cancel, leaving me with 3/2. All right, I would like you now to please pause the video, go ahead and do the U-tries, and then you can check your work, okay? Pause that video. All right, take a look. Let me move this out of the way. All right, so here are the first 4, and I'll leave it here for a moment, and then we can scroll on down. In the third one down there, you really can't simplify that numerator. Nothing can factor, so you're kind of just stuck with a really long numerator. All right, I'll go ahead and scroll down, and if you need to pause the video to see something a little bit more, please go ahead and do so. But here are the last 2. In the last one, it was simply opposites. You could have gone the longer route, and that's totally fine, but I noticed they were opposites, so it was a lot easier to just go ahead and take care of that and combine my numerators. All right, so I'm going to go ahead and pause or stop this video, so please do bring any questions to class. Definitely do the practice on this, guys. You've got to be practicing this concept, all right? We are done. Adios.